So we've discussed sine and cosine graphs and then how to get the equation from the graph. So now we want to talk about tangent. And tangent's a bit of a different beast, okay? Because when you take the tangent of minus pi over 2 or pi over 2, you can see I put it in a table there, you actually end up with undefined values. So it looks a little bit different, all right? Now we know the tangent is 0, 0, that's fine, and that means the tangent of pi as well is 0. So if you want to add that sort of to your table, we know the tangent of pi or minus pi is also 0. But what you have is a very different shape. So I want to show you the shape first. This is what it looks like. So at pi over 2, there's a vertical asymptote. And that's probably new to you. Probably haven't seen that on a graph before. So it just means that you can't get there. It goes up to infinity, but it never crosses that vertical asymptote. And the reason it's happening is because you're dividing by 0. Okay. If you imagine I'll just show you this just as sort of an aside. You remember sine over cosine? That's what tangent's equal to. So at pi over 2, you get sine of pi over 2 divided by the cosine of pi over 2. Now the sine of pi over 2 is 1, but the cosine of pi over 2 is 0. So you actually end up dividing by 0, and that's why you have this asymptote. Okay, and you have it at pi over 2, and you have it also at minus pi over 2. And then right in the middle, you have the point 0, 0. So it's a very different shape. Now, this repeats again right afterwards, okay? And so it's periodic like sine and cosine, but what's different is that it doesn't have a max or a min. You'll see I've written that there in big red letters, but it doesn't have a max and min, so it doesn't have an amplitude. It still has an a value, like if you're going to add in a, b, h, and k like we did with sine and cosine, it still has an a value, but it just doesn't describe the amplitude. There isn't one because it doesn't have a max or a min. Okay, the other thing that's different, or a few things that are different, the period, remember with cosine and sine, the period was 2 pi. Now it's just pi. It repeats every pi. And if you're wondering kind of why that happened, if you imagine back to the cast rule, which I assume you know, tangent's positive in quadrants that are directly opposite each other. Sine and cosine aren't. Okay, sine goes positive, positive, and then negative, negative. Sine does. Cosine goes positive, negative, negative, positive. So they're not different by 180, but these tangent goes positive, negative, and then it goes back to positive, and then negative, and then positive, negative. So it actually repeats every pi as opposed to every 2 pi. So that's different. Excuse me, its domain and range are different as well. Because with sine, we said the domain was just xer all the time. And with cosine, now with tangent, it's y that's always belonging to the real numbers, and it's x that has to be restricted. And the domain is pi over 2 plus n pi, okay, which means any multiple of pi times pi over 2. And then you can find your asymptotes and you can find your x-intercepts as well. Your x-intercepts are going to be 0 plus any multiple of pi. So in other words, if you add pi over here, pi is right here, you would have another 0 point. And the asymptotes are pi over 2 plus pi n. Again, pi is the period, so that's where that pi is coming from for all three of these. It's coming from the fact that it's the period. So then we want to say, okay, well, that's what the basic shape looks like. So what do these a, b, h, and k things do? And a, b, h, and k do the same things to the graph that they did for sine and cosine. So a affects the vertical stretch, b affects the horizontal stretch, excuse me, and also affects the period. H affects the horizontal translation, it moves left to right, and K affects the vertical translation. What's different is the stuff you're going to be asked to find. So you're not going to be asked to find the amplitude because there isn't anything, or there isn't one, and you're also not going to be asked to find the sinusoidal axis. And the reason you're not going to be asked to find the sinusoidal axis is these aren't sinusoidal. In other words, they're not able to be written as a sine or cosine graph. So you won't have a sinusoidal axis, you won't have an amplitude, but you'll still have a period. You'll still have vertical and horizontal translation. You'll still have a vertical stretch. Even though it's not called an amplitude, you'll still have an A value that does something, and the period is still affected by B. What you'll have that's new are these. The domain and the range are different. Okay, now you were still asked for the domain, but it was different. So now you have to kind of know what this looks like. It's very difficult sometimes to remember all of this formula. it's actually easier sometimes to just draw the graph of tangent and then notice where the asymptote is and say the domain is x can't be the asymptote plus the period times n. All right. So if you want to remember it this way, this is how I remember it. That's the first asymptote. And then this, that pi over b is the period. Okay. Period. So you can remember that the domain is x can't be the first asymptote plus the period times n. That's how I remember it. But the first, this is how you actually find that. But it might be easier just to draw the graph and then find it. Okay, the period's just pi over b now instead of 2 pi over b, but it's still b. And then your asymptotes are going to be found using this. And essentially, if you look at this, you might think, well, that's another overwhelming formula. I'm assuming you notice, if you look at them closely, that they're the same as this. The only thing that we've changed is the not equal becomes equal, but it's exactly the same formulas. So if you know the domain, you know the asymptotes because they're actually the same thing. It's just the domain is x can't be those because they are asymptotes, all right? So let's look at a few examples of this. We want to draw a tangent here, tangent of 3 theta plus 1. So what you want to notice first is your a value here is 1. It's the number in front. Your b value is 3, okay? Your h value is 0 because theta is not added or subtracted. Like there's nothing added or subtracted to theta, I guess is a better way to say that, and then k is 1. So that tells you there's a vertical stretch of 1, there's a horizontal stretch of 3, which means down here, your period is pi over 3. Then the h value is 0, which means there's no horizontal shift or horizontal translation, and there's k value is 1, so there's a vertical shift of 1 up. And then we need to state our asymptotes. Now our asymptotes are going to be pi over 2b plus h. So in this case, it's just pi over 6 plus h. H is 0, so it's pi over 6, and then pi over b is pi over 3n. Okay? So it's pi over 6 plus pi over 3n, which means your domain is x can't be those. All right? I'm not sure if we have it stated here or not. Doesn't look like it. So if we don't have it stated, we can say the domain is x can't be pi over 6 plus pi over 3n, where n belongs to the integers. All right, and then we're going to graph this. We're going to do the exact same thing we did with sine and cosine. The only difference is we're going to use a different set of points. So we're going to use for tangent, we're going to use these points, minus pi over 2, minus pi over 4, 0, pi over 4, and pi over 2. So we're going to divide them by b, so we're going to divide them by 3, and then add h, so add 0. So we're going to get minus pi over 6, minus pi over 12, 0, because we're dividing 0 by 3, pi over 12, and then pi over 6. And for ay plus k, we're just going to take y and add 1. So we can't add anything to undefined. It just stays undefined. But minus 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And undefined goes back to undefined. All right? And then you just plot those points. Okay? So we're going to use those 5 points every time. These are the 5 points we're going to use. And the reason we're going to use them is because they're just nice, easy numbers. And they are a full period. They're undefined to undefined, all right? And all the other y values are 0 or 1. So that's why we're using those particular values. You can pick any ones you want. It's just that those are nice. And they're nice because I've drawn the special triangle here just to indicate the tangent of pi over 4 is 1 over 1. And so is the tangent of minus pi over 4, except it's negative. But that's where we're getting that 1 and minus 1 from. It's from this special triangle, if you're wondering where that's coming from. So we're going to plot these. So we're going to go up here, minus pi over 6 and undefined. There it is. Then they're going to go minus pi over 12 and 0. So minus pi over 12 and 0 is going to be somewhere like here. Okay. And then 0 and 1 goes here. And we have pi over 12 and 2 is going to go here. And so my tangent graph is going to look something like this. And you're going to have to bear with me because I got to try to draw this, and it's a very small window of trying to draw it. But then you'll notice the pattern repeats. So if we wanted to, we go to asymptote, then we go to pi over 12 further than that. Okay, so half the way. Then we go another half and 1. Then we go another half and 2. And then we go another half in the asymptote. Then we do the same thing here. So 0, we go to 1. And then halfway in between, we go to 2. and then this would be another asymptote, and we could keep going for forever. All right, so you could draw more than one tangent line. This one would go like this. It just bends down like that. All right, so that's how we draw it. And what I'm saying about the domain is if you don't like all of this, okay, you can see that this is my asymptote, that pi over 6, right? So the first asymptote after the y-axis is pi over 6. And then you're just adding the period. And the period, we said, was pi over 3. So that's the period. Okay, so first asymptote plus the period. That's how you draw a tangent. It's as simple or not as simple as that, depending on how you look at it. All right, so let's do one more example, and then I will leave you to it. Might do maybe one more after that. But there's a bunch. We'll do 1 in degrees. I think we have 1 in degrees and 1 in radians, and I think we'll leave it at that. So we have, in this case, a is 1 because it's the number in front of the tangent. B is 2. H is pi over 3, and K is 2. Okay, so that tells me I have a vertical stretch of 1. I have a horizontal stretch of 1/2, which means my period becomes pi over b, which is pi over 2 now. My h being pi over 3 means I have a horizontal translation or a horizontal shift, I guess, of pi over 3 to the right. And then I have a vertical translation or a vertical shift of 2 up. Okay? Now, I'm going to do this a little bit differently. I'm not going to do the asymptotes like this, although you could. I'm going to do it from the graph just to show you what I mean by that. Okay? So in order to draw the graph, I'm going to do my first column, which is going to be minus pi over 2 and undefined. Then pi over 4 minus pi over 4 and minus 1. This is for tan x, remember? Then I'm going to do 0 and 0, pi over 4 and 1, and then pi over 2 and undefined. So I'm going to start with that. Okay? And then I'm going to do x over b plus h. So that's going to be x over 2 plus h. H is pi over 3. Okay, so minus pi over 2. This is where this gets a little weird. All right, so I'm going to do it over here in this blank space so you can kind of see what I'm doing. I'm going to take minus pi over 2, and I'm going to divide that by 2, and then I'm going to add pi over 3. So minus pi over 2 divided by 2 becomes minus pi over 4, and I'm going to add pi over 3. So then I have to write it as 12s, right? So they have to both become minus 3 pi over 12 and then plus 4 pi over 12. And then if I add that together, I get pi over 12. Okay, so this is going to become pi over 12. And then my y value is ay plus k. A is 1 and k is 2, so I get y plus 2. So that just becomes, that stays as undefined, all right? So it's pi over 2 and undefined. Then I'm going to do my next, or pi over 12, sorry, not pi over 2, I wrote that wrong. Pi over 12, there we go. Then we're going to go minus pi over 4. So we're going to minus pi over 4 divided by 2 plus pi over 3. So I get minus pi over 8 plus pi over 3. And that's going to make me go over 24. So I'm going to get minus 3 pi over 24 plus, and then pi over 3 is 8 pi over 24. So that's going to give me 5 pi over 24. Okay, so I'm going to go back up here and put 5 pi over 24. And then minus 1 plus 2 is 1. Now you might say, okay, I don't want to do this every time. I don't want to have to go through this whole thing. I don't either. All right, what you'll notice is if I just write this as over 24, if I write this, it'd be 2 pi over 24. So this is just jumping by 3 over 24. So the next one's going to be 8 pi over 24. Then it's going to be 11 pi over 24. And then finally, if you add 3 more, it's going to be 14 pi over 24. Okay, you can just jump by that same amount every time. So it saves me a little bit of time. Now, yes, these reduce. 8 pi over 24 does reduce, so does 14 pi over 24. But I'm just going to leave them like that for now. And then what I'm going to look at is the y value. So minus 1 plus 2 is 1, 0 plus 2 is 2, 1 plus 2 is 3, and then undefined again. So then what I'm going to do up here is I'm going to go up by, you notice this is pi over 12, so I'm going to jump by pi over 12 and undefined. So that means I have, here's my asymptote. Okay, all the way down. And then the next point is 5 pi over 24, which is pretty close to, if you kind of go up by halves, all right, that's pi over 24, that's 2 pi over 24, 3 pi over 24, 4 pi over 24, so that's 5 pi over 24 is right there, and I'm going to be at 1. So 5 pi over 24 is at 1. Then I'm going 1, 2, 3 more over 24, and that's at 2. Then 1, 2, 3 more, and that's at 3. Okay, and then I'm going 3 more than that, so 1, 2, 3, and at 7 pi over 12 or 14 pi over 24, I've got my other asymptote. All right, and then I can draw my graphs. My graph is going to look like this. All right, it's going to kind of go down like that and up like this. I sort of missed out on that point, but you get the idea. And I'm drawing this with the technology that I have, and it's not that great. So I'm going to try this again, just to make it a little bit more through the points. There we go. That's a little better. It doesn't drop off like that quickly, but there you go. That's basically what it looks like. All right. So to get back to my asymptotes, now I know they're at pi over 12 plus the period. So the asymptotes are x is equal to pi over 12. That's where they start. And then plus the period, which is pi over 2 times n, where n belongs to real numbers. Okay, and that means my domain is x can't be pi over 12 plus pi over 2n, where n belongs to the real numbers. Okay, and my range, which I don't think I have stated yet, is just y belongs to real numbers. So that gives you another example of drawing a tangent graph. It's fairly simple, I think, once you get the hang of it. I think we'll do one more, this time in degrees, and then we'll leave it at that, and you can practice. There's a few more in the notes that you can practice with, okay? So let's do this one in degrees. A is going to be 1, B is going to be 3, H is going to be 30, and K is going to be 1. So A being 1 tells me I have a vertical stretch of 1, or none, I guess. B being 3 tells me my period. My period then is going to be, and you have to be careful here because we're in degrees now, so the period is going to be 180 instead of pi divided by 3, and that comes out to 60 degrees. 30 being H means I have a 30 degrees to the right. Okay, horizontal shift, and this means 1 up. Now, I can also state my range. Pretty easy to do that. Y belongs to real numbers. I'm going to hold off on the asymptotes and the domain. So the domain I'm going to put here, the asymptotes I'm going to put here, but I'm going to wait. Okay? And what I'm going to do first is I'm going to go down and I'm going to do my table to figure out where I'm going. So I'm going to just switch them to minus 90 and 1. Sorry, an undefined, not 1. And then minus 45 and minus 1. 0 and 0. 45 and 1. And then 90 and undefined again. That's my y equals tan x. And then I'm going to do x over b plus h. So x over b becomes x over 3. I'm going to divide by 3, and then I'm going to add h. And h is 30. Okay, and then my y's, I'm going to do ay plus ka is 1 and k is 1, so it just becomes y plus 1. So 90 divided by 30 is 30. 90 divided by 3, sorry, is minus 30 plus 30 is 0 and undefined. Minus 45 divided by 3 is minus 15. Minus 15 plus 30 is 15. And minus 1 plus 1 is 0. And then you can notice these are jumping by 15 every time. So this is going to be 30. This is going to be 45. And this is going to be 60. And then I'm going to just 0 plus 1 is 1. 1 plus 1 is 2. And undefined is again undefined. So I look at my asymptotes, they're already drawn in here at 0 and at 60 for me. So 15 is halfway there, 15 and 0. Then I'm at 30 and 1. And then I'm at 45 and 2. So it looks like this. And then we just kind of go along, go through those points, and go back down the other side. Okay? Not running through the asymptote, but running up towards it. So then I'm going to look at my domain. I'm going to say x can't be the first asymptote, which is 0, plus the period, which is 60k. So I'm going to say it can't be 0 plus 60k, or 60n. I guess we've been using n, where n belongs to the integers. And that means our asymptotes, our x is equal to 0 plus 60n, where n belongs to the integers. All right, and that's my answer for that one. And I think I'm going to leave it at that. There are some more here. I'll just scroll through them on the video so you can grab them and try them if you want to. There's the next one. There's another one. There's another one. Actually, that's the same one, I think. And then here's a final one. So you can try those on your own and get the solutions from your teacher, but I think you've got enough of an idea of how to do it now. So we'll just leave it at that for now.